Earth is the blue planet. More than two-thirds of it is covered in water. There are over 1 billion cubic kilometers of it, filling every ocean. But here's the strange part. Earth had no business having any water at all. To see why, we have to go back to the day the Earth was born. 4.5 billion years ago, Earth formed from a disk of dust circling the young sun. Close to the sun, it was blisteringly hot, a world of molten rock. At that temperature and distance, water simply cannot survive as ice. Astronomers call the boundary where ice can exist the snow line. It sat far out, near today's asteroid belt, well beyond Earth. Earth formed on the dry side of that line, from bone-dry rock. So the newborn Earth should have been a parched ball of stone. So where did all that water actually come from? For decades, scientists have chased two main suspects. To catch the culprit, they needed a fingerprint. And water has one. Some water is made with ordinary hydrogen, some with a heavier twin called deuterium. The ratio of heavy to light hydrogen is a source's signature. Every reservoir of water in the solar system carries its own DH value. Match the fingerprint to Earth's oceans, and you've found the source. Suspect number 1, comets. Comets are dirty snowballs from the cold outer solar system. They are made largely of water ice, so they seemed the obvious answer. A rain of comets could easily have filled the ocean. In 2014, a spacecraft called Rosetta caught up with comet 67P. It measured the comet's DH ratio directly, for the first time. The result, 67P's water was far heavier than Earth's oceans. Most comets, it turns out, don't match. They delivered only a small share. Suspect number 2, asteroids. Not the dry ones, a dark, carbon-rich kind called carbonaceous chondrite. These rocks hold water locked inside their minerals as clays. A single such asteroid can be up to 10% water by weight. And their DH fingerprint matches Earth's oceans almost perfectly. That makes water-rich asteroids the leading suspect. But there was a problem. These asteroids formed far from Earth. How did they cross the solar system to reach us? The answer is that the early solar system was pure chaos. The giant planets did not stay where they were born. As Jupiter and Saturn shifted, their gravity flung distant bodies inward. Water-rich asteroids were hurled toward the young Earth. Around 4 billion years ago came the late heavy bombardment. For millions of years, impactors hammered the inner planets. Each wet asteroid added its cargo of water to the Earth. Drop by drop, impact by impact, the oceans began to grow. The scars of that era still pockmark the face of the moon. Much of your drinking water may have ridden in on an asteroid. But asteroids may not be the whole story. Some water may have been built into the Earth from the very start. As Earth grew, water could cling to the dust grains that formed it. And astonishingly, a vast amount of water hides deep inside the planet today. Hundreds of kilometers down lies a mineral called ringwoodite. Ringwoodite can trap water inside its crystal structure. In 2014, a tiny diamond from the deep mantle proved it. Trapped inside that diamond was a fleck of water-bearing ringwoodite. It hinted that the mantle may hold as much water as all the oceans, perhaps several oceans' worth, locked in the rock beneath our feet. Some of that deep water may have risen up through volcanoes over time. However it arrived, the young Earth was wrapped in scalding steam. As the surface finally cooled, that steam began to condense. Then it rained and rained for thousands of years without stopping. Water pooled in the basins, and spread into the first great oceans. By about 4 billion years ago, Earth was a water world. We can prove water was there that early, thanks to tiny crystals. Ancient zircons, 4.4 billion years old, formed in the presence of water. Earth had oceans almost as soon as it had a solid crust. That early water changed everything that followed. It lubricated the plates, letting the continents drift and grind. It steadied the climate and carved the land. And in its depths, the first life may have stirred. Yet the full recipe of Earth's water is still debated. How much came from asteroids? How much from within? To settle it, we are now going to the asteroids themselves. Missions like Hayabusa 2 and osiris-rex brought pieces home. Their samples of Ryugu and Bennu carry water and the seeds of life. Bit by bit, the story is coming into focus. Earth's water was not one gift, but many. Rock from space and rock from below, rained into a single blue world. So the next time you pour a glass of water, look closely. Those molecules are older than the oceans, older than the Earth's crust. A little piece of outer space, sitting in your hand. If you enjoy this kind of deep science, subscribe, and I'll see you next time.